In this video, we will be multiplying mixed numbers. Related videos and skills that are needed before multiplying mixed numbers include multiplying and dividing fractions and converting between mixed numbers and improper fractions. If at any point during this video you're forgetting some of those skills, you can go back and watch those related videos. In our first example, we have 1 1/3 times 2 1/5. Down here in our left bottom corner are our steps to remember. These are step-by-step directions to help us solve a problem like this. Step 1 says we're going to need to change the mixed numbers into improper fractions. We know that to change a mixed number to an improper fraction, we can use something called the triangle trick. So let's use that trick on these two mixed numbers. 3 times 1 is 3. 3 plus 1 is 4. Back over that same denominator of 3, so 4/3. Moving to our next one, 5 times 2 is 10. 10 plus 1 is 11. Back over that same denominator, so 11/5. Okay, step 1 is done. Step 2, we're going to go ahead and multiply the numerators, and then in step 3, we're going to multiply the denominators. So 4 times 11 is 44 in our numerators, and 3 times 5 is 15 in our denominators. Last step, it says, if needed, change your answer from an improper fraction back to a mixed number. We do have an improper fraction here, and in almost all of these mixed number problems, we are going to have to do step 4. So to go from an improper fraction back to a mixed number, we know that we can divide the numerator by the denominator to see how many groups of 15 will go into 44. So we can start thinking about 2 groups of 15, that's 30. 3 groups of 15 would be 45, and that's going to be too much. So we're going to go with 2 groups. 2 times 15 is 30. We're going to take that away from our total of 44, giving us 14. So we're going to have an answer of 2 as our whole number with 14 left over that same denominator of 15. This cannot be reduced, so our final answer is 2 14/15. Here's our next example, 2 2/3 times 1 3/10. Step 1, again, we're going to need to change these mixed numbers into improper fractions using our triangle trick. So 3 times 2 is 6. 6 plus 2 is 8/3. Multiplied by 10 times 1 is 10, plus 3 is 13/10. So 8/3 times 13/10. We're going to multiply our numerators, then multiply our denominators. 8 times 13. I'm going to do some math off to the side here. It's going to be 104. And 3 times 10 in our denominator is going to give us 30. Now we need to change this improper fraction back to a mixed number. So essentially we're doing the numerator divided by the denominator to find out how many groups of 30 will fit into 104. So if we're counting by 30s, 30 times 2 would be 60, 30 times 3 would be 90, 30 times 4 would be 120. And that's too much. So we're going to do 30 times 3. So 30 times 3 is 90. We're going to take that 90 away from our 104. We have to borrow. So we have 14 left. So our mixed number is going to be that 3 as our whole number because 30 goes into 104 3 total times, with 14 left over, and our denominator is going to stay the same, so over 30. Now in this problem we can still reduce. We can reduce 14/30. We know this because both 14 and 30 are even numbers. So one good trick is just to cut them in half. So 14 divided by 2 and 30 divided by 2 is going to give us a fraction of 7/15. and that is in smallest form, so our final answer is going to be 3 7/15. One more example, we have 7 1/3 times 2 2/11. Step 1, we've got to change these mixed numbers into improper fractions. 3 times 7 is 21, plus 1 is 22, and we close that off over 3. 11 times 2 is 22, plus 2 is 24 over 11. Next step, multiply the numerators and multiply the denominators. Now this problem we can see is going to take a few extra kind of steps because we can't really do 22 times 24 in our heads. Some of us might be able to, but most of us are going to have to use a different multiplication strategy to figure that out. So let's quick set up a lattice. 22 times 24. It's not going to be the neatest looking lattice, but we're trying to do some quick math here so we can get on with the problem. 2 times 2 is 4. 2 times 4 is 8. 2 times 2 is 4. And 2 times 4 is 8. Add our diagonals. 8. 8 plus 4 is 12. Carry the 1. 4 plus 1 is 5. And we've got nothing in that final diagonal. So 22 times 24 is 528. So that's our numerator. And our denominator, 3 times 11, is 33. So we've got another job here. We've got to find out how many groups of 33 can fit into 528. This is going to require some long division. So I'm going to set up a long division problem over here. 528 divided by 33. So how many 33s can fit into 52? 1. 33 times 1 is 33. Subtract. 12 minus 3 is 9. 4 minus 3 is 1. Bring down our 8. 33 goes into 198 how many times? So I'm going to do some math over here. I'm going to try 33 times 5 and see where that gets me. 5 times 3 is 15. 5 times 3 is 15 plus 1. 165. Can I go 33 times 6? 6 times 3 is 18. 6 times 3 is 18 plus 1. 198. It's actually going to perfectly fit into 198 6 times. So 33 goes into 528 16 times. It's going to make even groups into there. So our final answer is just going to be 16 because we do not have anything left over. So we are not going to be able to make a mixed number. The whole number answer is 16.